Hello. Hi. SolarLune here, and welcome to my game development stream. I am SolarLune. I'm the creator of Master Plan. I'm the creator of Tetra 3D, and I'm the creator of this game I'm working on. And yes, welcome to the stream. So, hello. How's everybody doing today? Yeah. So basically, this time around, what I am well, let me show a little bit of what I've been working on. Let's do that first. All right. I didn't commit any of this. Okay. Let me just do this. There we go. Okay. All right. So yes, this is what I've been working on. This is what's new. So this is alpha ordering. Basically, I improved alpha ordering of transparent stuff. So this is a plane in front of a blue plane in front of a like dark blue navy plane, and you can see there's a background image being drawn here. This red plane is additive, so you can see it makes the blue plane turn pink rather than it's not transparent, it's additive, so it's adding there. And then this green plane is transparent, so you can see how it's not additive, it's just ordering properly. And then this is another composite mode, which is clear, so you can basically look through, and it's setting the background to be alpha 0, so you can see the background image here through this three-dimensional plane, which is cool. Yeah, so that's something I added and worked on the sorting, alpha sorting, and stuff like that, which is good. Something I noticed. We will make a new window here. Something I noticed about the game is that when we display the scene from this angle, you can see the FPS drops. So it goes from 75 FPS to previously this was like 60. Now it's even lower. I guess it's just the angle that I'm drawing. And I believe. Oh, I see. I guess this looks like this because it might not be stretched properly. That's okay. This is not that important. But in any case, oh, now it's like 55. But basically, the FPS is low probably because of the rendering things. So you can see, for example, the total render time is like 3, 4, 6 milliseconds. So in order to maintain 60, you have to maintain 16. Anything below 16. So these numbers should basically facilitate a 75 FPS or 60 FPS game, but we're definitely getting lower FPS. We're getting 45, 50, 55 FPS from this direction, when we're looking at the scene from this direction, despite the fact that the render time is low. Like the time we're spending rendering isn't high enough to make this. So I think there's a couple of theories. One theory is that basically it's spending time flushing the graphics, the draw calls to the GPU. So basically, we're only spending this much time in rendering, but we're waiting still for the GPU to return from drawing the things on screen. And I believe that's the case because we're mixing a lot of draw calls here. So like the fences are all, I believe they're all clip alpha, which is bad because you have to kind of swap between you have to like swap between context, not context, but like images when you're drawing, because you have to draw to a clip texture and then you have to composite that onto the main color texture and stuff like that. So in other words, we want to try to limit that. So this what I'm trying to say is this stream is probably going to be more of an optimization stream. I might try to optimize this scene, like, you know, this, our game, but I think also it would be good to optimize the rendering process if possible. So one thing that I know I can do is I can try multi-threading, to basically kick the render frame time from the main thread over to another thread or 2 or 3 or 4 other threads. That way it can happen, you know, ideally faster rather than being so slow. Yeah, so we can try that. So that we'll do a couple things here, and we have an example that makes this a little easier to see. So this might be bad on stream or on video, I'm not sure, but this is the default stress test. And I'm going to keep it small so that the video hopefully doesn't get crunchy. But this is a default stress test where we have 4 objects, essentially, 4, excuse me, 4 different draw calls for these cubes. So all of these cubes are being placed programmatically, and then they're merged together into a single scene, and then we go ahead and draw the scene on screen. So there's a lot of cubes here. There's, you know, I don't know how many exactly, 69,192 triangles divided by like 12 triangles per cube. So there's a few thousand triangles, I'm sorry, a few thousand cubes here. And this is a good scene to do stress tests on, because this allows us to basically see how our frame time is kind of in amalgamation in a sense. And then we also have another stress test. I also have another stress test now, which is basically the opposite, which is just a lot of cubes individually. So we can basically test out the process of rendering. And so you can see here an example of what I think is slowing down our actual game. The frame time is like 10, 9, you know, maybe even lower milliseconds per frame, or I'm sorry, per second. But our frame rate is still low. It's still like 19, 20 FPS. And that's because we're spending time waiting for the graphics card to flush, I believe. I believe we can press, let me see, can I press P to profile? Yes. So let's do a quick profile. And so after about 10 seconds, you can see in the terminal at the bottom, it says beginning CPU profile, and then it will be, yeah, say CPU profiling finish. We will make the text a little bigger. And then we have a profiling object here we can examine. So we'll do that. We will use Go Tool pprof, export in SVG so we can see it, and then we'll see what's gonna happen. What's up? I'm pretty sure. Yeah, so you can see here on the right side, this is our main loop. It's a little small. I'm zooming in. So we can see we have the draw, well, basically 1.2 seconds were sampled, or I guess 9 seconds, 9.92 seconds, or 10 seconds were sampled, but out of that, like 1.2 seconds were not spent here, but this is like where this focuses on 1.2 seconds out of the 10 seconds. So if you scroll down, you can see where basically most of the time is being spent here. So it's not really accurate to the actual time we're spending, because we do have, you know, times where we're waiting, you're right, for the CPU to do things, or one thread might be doing nothing while another thread is working, or we're waiting on the GPU or whatever. So the profiling isn't going to be 100% accurate, but we can still examine it to learn information. So here we're looking through the draw loop. We can see basically how the time is broken down. So we're spending some time rendering. All right, I guess we're really spending most of the time or all of the time rendering. And so you see out of 1.1 seconds, 0.2 seconds are spent here. And then there's, you can see the breakdown elsewhere. So draw triangles, draw image, draw triangles, etc. But you can see over here, it's a redder result. And you can see graphics command Q flush, and that's really where the triangles are being rendered here. So draw triangles, some of it is being spent here, some of the time is being spent here. but we can see that the seagull call is really where time is being spent because we're, I guess actually, it might not be so much that we're spending time waiting for the GPU, but rather we're spending time calling seagull. So we want to limit the number of times we call seagull, if possible. So we can do that a couple of ways. One is to try to avoid rendering individual objects if possible. Another way is to, well, that's the primary way to optimize this problem, is spend less time rendering individual objects, because then we can send more triangles at a time to the GPU. It might be possible. Let me see. Let's take a look at the camera code. It might be possible for us to basically render multiple objects in a single draw call, kind of like automatic merging of meshes. That is something that I started to do, but I didn't stick with because of some issue. I started working on that, but then it was like, that's not, it complicated the code or something, and it didn't feel like it was really worth that much. Yeah. So there's a couple things we can do. The first thing is to basically try to multi-thread this process so that we do as much as we can on multiple threads, and then we basically just like do the final step, which is rendering depth and rendering color later, because all the other stuff can kind of come earlier and be multi-threaded. So basically, what I'm going to do is I'm going to split this up into multiple stages, multi-thread as much as I can of the 4 stages of rendering an object, and then once we're done, we actually merge it all together into a single thing that gets pushed to the GPU on our main thread, which I don't think we can push to other threads. I don't think draw triangles is concurrent safe. So because I believe it has to happen on the main thread. So that's just the way it is. So that's fine. So let's get some music before I get too far in. Let's go with that. Something a little lighter. Let me get a mint. Okay. Okay. Oh, I did delete that. Yeah, I was like, did I delete that CPU information? All right, well, that profile. That profiling result. All right, that's fine. Okay. Let me think. That sounds horrible. I gotta fix that ASAP. that song is horrible. Let's go with this. No. This is fine. All right, so yeah, I think what I'm gonna do is we're gonna break this down to multiple stages. So we're gonna write the stages down so we can kind of like make functions or make pieces that kind of streamline it, because it works currently fine, but it's a little like mixed in terms of how it all works. So first things first, we want to do culling, right? So Frustum Culling and then we do triangle transformation, or vertex transformation rather. We can just do it like this: culling, vertex transformation. Then I think we could do lighting. Or no, wait, I guess clipping. Vertex culling. So model culling, vertex transformation, vertex culling. I think we could probably have a set, and this is something, because the way this works is I have basically a vertex list that I have for I have a vertex list for like positions of the vertices, and then I have to color them according to the depth and UV values. If we're doing clip alpha, then we render the depth. So let me think. Let's see, render depth. So depth rendering. Lighting could be done. Because that could also be multi-threaded. So we want to basically make it so that as much as multi-threaded as possible, and then as little that is unmulti-threadable is not multi-threaded. So after this is done, we should build a multi-thread, or rather single thread from this point down. Then we do depth rendering. Do I not do depth rendering here? I do depth rendering here. Is this not depth rendering? No, this is color rendering. Okay. That's it. Okay. So then we do depth rendering, and then we do color rendering last. Yeah. So we want to do lighting here, not because it couldn't come later, but because lighting, like at this point, anything that any triangles that remain should still exist. Vertex culling happening earlier would mean, yeah, that basically if a vertex is cold for whatever reason, or triangles are cold, I guess that is the actual name. If triangles are cold because they're off screen or whatever, then lighting doesn't need to happen. So this is dependent on triangle culling. Triangle culling is dependent on vertex transformation. Vertex transformation doesn't need to happen if the model is cold. So that's the process. That's basically what currently is happening, but we want to make sure that it works as it should. So let's see. I think we will make this a little. We could break this down to multiple functions. So we have model culling, vertex transformation, which actually we don't need to do because we already have a function that does this. And then we have triangle culling. Then we have lighting. And then we have render. So, and I can put this over into another thing. There we go. So this way we have kind of a segmented series of steps, so we don't have to like guess so much. And multi-threading should be easy-ish. Let's see. Right, so the thing about multi-threading is you want to make sure that you have essentially a like, the way this works is we are sending triangles to the GPU. So we are sending basically a list of triangles that have been set, or vertices that have been set with their properties, like where they draw or what UV values they have, as well as indices. So let's say you have, let me break out a spread for this. So let's say you have two objects, right? You have one object, you have two objects. Okay, so you have two objects here. This one is A, this one is B. Okay, so you have A and B. Now the idea is when one thread is working on A, the second thread is working on B. We could split it up so that like multiple threads can work on a single object, which is probably for the best. But the thing about multi-threading in a single object, especially if it has a lot of like vertices, is some of the vertices will be skipped and others won't. So let's see if we can break. I guess what I'm trying to say is, let's see if we can break this up, break a single object up into multiple threads. So let's say we have, object A. It has, let's say, two threads. So that's, or three threads. So that's 1, 2, 3, right? So this is the first thread. This is the second thread. This is the third thread. If the first thread gets through, and let's say the camera is somewhere like right here, viewing something an angle like this. So thread 1 can look through all of its triangles, all of the vertices, and basically be like, all right, let's transform all of them. And wait. Okay, so yeah, model culling. So that's done on, I guess that's done on the main thread. Then vertex transformation is done on is broken up into 3 threads. So the first thread transforms its vertices. Then the second thread transforms its vertices, and the third thread transforms its vertices. Let's see. Transformed vertices. So this is what we break up into multiple threads. Okay, this is where I was. Yeah, this is where I was. Well, no, I think all vertices are transformed. Break. Try. Okay, yeah, so. Alright, so if we were to multi-thread this, we would be looking at basically a selection of triangles. So this would be the first set of triangles. So it would be like, okay, triangle, 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 triangle. Second thread, triangle, 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 triangle. But then over here, it's like, okay, I'm going to start setting these to be invisible because, like for example, you're running a transform function that's basically setting the vertex position to be nil. So it's making the triangle invisible. So these turn invisible, let's say. So the vertices aren't transformed, but the triangles are still there. We still sort the triangles. We still sort the triangles. We still sort the triangles. Yeah, we still sort the triangles. And then 3, it still needs to transform its triangles. Does it need to transform its triangles? Yes, because it needs to know if it were to determine that the triangles were outside of the frustum, it would need to transform them to know where they are anyway. So that's fine. So we have to transform the triangles. Okay. It's sorting them by depth. Okay. And then triangle culling, which is here. triangle culling them if they're either off screen, if they're too far, if they're too close, or if they're facing the wrong direction. So that can be multi-threaded. If the triangle is not appropriate, or if it's cold, then we just skip adding it. So in this case, each thread has its own set of triangles that it would basically be like adding triangles to. So like 1 has a series, 2 has a series, 3 has a series, and then we just add them in sequence. So the final result of rendering the object is just 1 plus 2 plus 3 in terms of the triangle set. Okay, I think that should be fast enough. So yeah, so I'm trying to figure out like how to do this. The best way to multi-thread, because there's 2 ways to multi-thread basically, as you can see. One is multi-threading per object. So you can say, like, for example, we have 10 objects to draw. We'll have thread 1 draw objects 1 through 5. We'll have thread 2 draw objects 6 through 10. That's multi-threading. While one thread is doing something, drawing the first 5 objects, the second thread can also be drawing, or at least transforming and setting up the second set of objects. Then in an object, you have to transform the triangles, and that is by far the most dense, most data dense part, and that also can be multi-threaded. So I'm thinking that maybe we'll set this up so that we can multi-thread multiple pieces, because we have a couple of methods of multi-threading, right? So anything before this can be multi-threaded. So we can multi-thread this entire thing. And we can also multi-thread this specifically, vertex transformation. So maybe we could break it up so that, let's say we have 3 threads. Well, let's see, how many threads can you have at a given time? Every computer is at least dual core, right? There's no such thing as a non-dual core computer. Should I hard code threads? Probably not, right? Probably not. Okay. Probably not. Well, no. Well, no. All right, so let's do this. Firstly, I would like to try multi-threading on stress 2. So we'll do the per object multi-threading first, I guess, because it's probably the easiest one to do. I would assume it would be easiest. Because we have to transform the vertices anyway. Yeah. We have to transform the vertices anyway. So what I'm thinking is maybe each vertex should hold an Ebiton vertex for both depth and color. Let's see. A vertex contains... Does it say? It does not say. Okay, so let's see. How big is the float 32? Is it 32-bit? I guess that's a stupid question. Is a float 32-bit? Is that 8 bytes? It must be 8 bytes, huh? 32 bits, yeah. Or is it 4 bytes? Let's see. 8 bits is a byte. So if it's 32-bit, that means it's 4 bytes. Yeah. So if it's 4 bytes big, then let's multiply. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 times 4. It's 32 times 2 That's 64 bytes. Wait, yeah, 8 times 4 bytes. That's 32 bytes, 64 bytes per vertex. So then if you had, let's say, let's look at our example scene. In this example, it's weird. I guess I was just not looking at it. In this example, we have 441 cubes. So if you have 441 cubes times 64 bytes, that's 28,224 bytes. That's 28 kilobytes of memory. That's not too big. It's not a huge deal. Wait, I said, oh, 441 times 64. That's a single vertex. So that's 28,224 bytes for a single vertex, which is, which is a cube. Or which is just a single vertex. If we wanted a cube, we would have to have at least 12 vertices, right? Because a triangle is 3. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Times 12, that's 338,688 bytes, or 338 kilobytes, which isn't that much. So let's say it's 28,224 for 400 objects, and they have an average of I have the calculator. Can I open another calculator? No. Okay. I can. All right. So let's say we have a non-trivial mesh, right? Let's say it's a building. Let's say it's, this is still low poly. Let's say it's 200 polygons, which if you multiply it by 2, because it's a polygon, that's 400 triangles. So this times 400 would be 11,289,000 bytes. So that's 11 megabytes of memory. That's not that much. So instead of the game being instead of this being really coming down. Let's see. Stress 2 is currently 42 megabytes. So this wouldn't be obviously increase of 11 megabytes. Your bytes, kilobytes, megabytes. Yeah, it wouldn't be 11 megabytes. It would be probably this number bigger. So that would be 338 kilobytes. So it would be not that much of a difference. It would be like 44 megabytes instead of 42 megabytes. So a pretty minor change for possibly better performance. Because basically by putting vertices directly in the model, it makes it slower to clone and create models. But the upside is we no longer would have to loop over the vertices multiple times. Because currently we're doing that multiple times. We're looping over the vertices once to transform them. We're looping over them again, or at least the triangles again to cull them. We're looping over the vertices in the triangles to set their colors. And then we do it again here for the vertex colors. Then we do it again for lighting here. Because I mean we have to do it for lighting. So this might be a lot better. Okay. All right. So I think it's worth at least to try. So first things first, we'll do just the per object culling here. So we're going to set this up so that it works in multiple stages, and we're going to try to loop through each vertex or triangle once rather than looping through multiple times. All right, so let's give it a shot. Okay, so these are our steps. Transforming vertices is not here because it's already in the model. Which should it be even in the model? We have to pass the camera. We also have to pass the mesh part. So maybe we should move this to camera. I feel like we should. But then we have to have the vector pool in the model. That seems wise. Seems fine. Do we even use the model? Because we use the mesh part, huh? To loop through the triangles. Yeah. So either this should be on camera or this should be on mesh part. Let's put it on camera. All right. So transform vertices goes here. Model is mesh part. Model. Oh, there's no model in the mesh part? Oh, mesh part. For some reason I'm thinking render pair. Let's make it take a render pair. Okay, so pair dot model. Pair dot mesh. There we go. Okay, so model dot vector pool reset. So yeah, multi-threading this is going to be its own thing, which is good. I think that's probably fine. So this concept is here. So transform vertices is here. Render is here. Cull model, then transform vertices, then cull triangles, then apply lighting, then render. Okay, so these are the steps. Actually, I guess we could put it in the render pair. And then we could put the camera in the render. Oh. Wait, hold up. What if... Because we have to take a render pair anyway. So what if we put this entire thing... Well, no, that's probably fine. Because we want to multi-thread as much of this as possible. So what's this? We want to multi-thread this entire process before we get to the rendering step. Let me think, hold on. What if instead of solids and transparents, we just had a list of renderables and we just step through them in order? Solids, transparents. I'm thinking. Okay. Well, let's break this out into pieces. That might help us to kind of get a bead on what we need to do. So this is the first step. Okay. Then we have transform vertices. Okay. We don't need a camera. We need render. There we go. Okay. Model is Okay. All right. So this should be basically the same so far. So transforming the vertices. Okay. This also can go here. Hold up. Let me make sure I put this in the right order and placement. So after the debug info goes, total tries plus equal. I see. Okay, so this goes between mesh. All right, and drawn parts plus plus. Okay. Here we go. So this should go here. This really could just take a render pair. Hello, Carl, Otto. Welcome to the stream. Hello indeed. Okay. All right, so this might cause like a little bit of a race condition to do it this way. But we'll need to access this all at the same, not all at the same time, but we'll need to access this debug values together. Got to figure out how to multi-thread condition. All right, so let's see. So model mesh part. Okay, so we're gonna say camera dot pull model. So we cull the model, we transform the vertices. And then cull the triangles. So really, this is just going to be triangles. Apply triangles. Cull triangles. We want to do this once, and then also apply lighting. Okay, so cull triangles is going to be here. So this is where we loop through all of these triangles. Here. Full model. Okay, so tries calling source W source H. Okay. Oh, we gotta put it. I see. All right, so we'll put this here. All right. Okay, there we go. So VP matrix is always the same. It is. All right, so this takes VP matrix. Vertex less index. So I guess we can do this. We can do this here. False. Alright, we can do it like this. And instead of a bool, this can return an int. And then we can say index equals this. There we go. So this is basically what vertex list got set. Okay. Tries. Match part. He's calling us true. All right. Images go to nil. Then image is the default image. For try and range tries, the default image. 4x4. Okay. You know what? Let's make it smaller. V0. Yeah, let's make it smaller. The smaller it is, maybe the faster it will be to blit. V0 try versus 0 transformed. Okay, so we're transforming it. Okay, P0. Guess we'll get to put this up here. Let's put it here. Cam width. Okay, so we have to get the camera size. Image. Oh, yeah, that's true. Mesh part, material, texture. All right, let's do this. Go. All right, so I think image was here. Not enough arguments in call to render pair.texture. How so? That's the first time I've seen that. That's strange. All right, well, I guess it doesn't really matter. It can be a pointer. It's fine. Oh, whoops. That's why. Okay, never mind. There we go. Pair.texture image. Do we use image anywhere? do use it a lot. Okay. Okay. I thought we use. Do we not use? Do I not use image? I guess no. I don't. Okay. It's strange. I'll use it at some point, so we'll examine that later. Okay. All right. So here's where we get a little tricky. So if we're rendering the depth map, then we. Wait, do I? Okay, so yeah, if we're rendering the depth map, we want to set the colors, but we also want to set the colors of the color map if we're not rendering the depth map. So my idea here is to basically make... Well, we can do this a couple of ways. One way is to have a color vertex list and a depth vertex list, and then just set them both at the same time. Or place them on the objects and go that route, which I guess is faster to do it this way. Something like that. And then over here, we just do the same thing for both color and depth. I guess we can do it like this. And if we're rendering depth, then we do this. I guess we could also loop. Well, I guess, yeah, this is fine. If we're rendering depth, then we do this. And then if we're not, or regardless of whether we are or are not, we do this. These are all depth. And then, so both depth and color need to have their UV values set. Oh, but we have to loop through the vertices to do so. Am I looping through the triangles? Yes. Okay. All right, so we're gonna loop through the vertices. And if we're setting depth, do that here. Or was it down here? So we're setting the depth here. Then if otherwise we set the vertex colors here. And then also also, hold on. So rendering depth. Otherwise we set this. We need to set the source here, this stuff. All right, that should work. Like this. All right. So we're setting all of the necessary information and data at once. We're culling triangles. Vertex list plus equal 3. Okay, cool. List index rather plus equal 3. And then over here, lighting, that's done over here. If lighting is here. Lighting can be out here. Well, not here. Hello, just wondering, I'm new here. Do you use some libraries for graphics and etc. apart from Ebiton? I use Go SDL2 for Master Plan, which is a project planning software that you can get on itch and Steam, which is a great project planning software. I recommend it heavily. If you want to support development, please feel free to check it out. Links in the description. But for graphics like in Go, for Gamedev, Ebiton is what I would generally recommend. Not because it's particularly deep for like graphics or UI, but because it just works really well. It works well. Sketchton says, hey, hello. Hi. All right, so pair. I guess we'll pass the scene as well. And over here, we can pass the scene. All right, so if this works, index 0. Color. Oh, I see why I did that. Okay. For light in range lights. Oh, lights needs to be determined elsewhere. Doing some programming too. Very nice atmosphere. Yeah, thank you. Thank you. Yeah. A nice chill stream. So lights are being determined out here. And then we want to pass it in. So that's what we'll do. Because I'm just like, is there another way to do it? No? Okay. Lights. Light.begin model. Let's see. Light triangles. Okay. Can we just reverse this? There we go. If anyone's like wondering what I'm doing, I'm working on multi-threading. Working on multi-threading my rendering system. So the camera gets cold. Then we, yeah, this is gonna pause. Yeah. Oh, that's not gonna work, will it? This is what, yeah, okay. So this is where the issue comes in, because I'm modifying, like I'm using this variable vertex list index to basically like indicate where our triangle list is. Like we have a triangle list and we're stepping through and like transforming the triangles, and then we might discard them if they're being cold or things like that. Which is fine, but the problem comes in because, like, we can't have two threads both touching the same variable at the same time. Like, thread 1 can't be writing it while thread 2 is either writing or reading. Or something. Maybe it's fine if one is writing and the other is reading? I don't remember. I thought that it was like, that's fine. It just might be old. But now I'm thinking, doesn't that cause a race condition? I don't know. I think it still causes a race condition. So we'll need to do this a different way. We'll need to make a thread. Like each pipeline. Maybe I should make a thing for this, like a pipeline or something like that. Like I could make a render pipeline object, and then we can run a go routine to like render it. And each pipeline has its own like variables. You can use a read-write mutex. It allows multiple reads at once, but all others stop for a single write. Yeah, that's not gonna work. I mean, that's a good idea, but that defeats the purpose of multi-threading here, because all of my threads will be touching the same variable heavily, which is color vertex list. That's where I'm storing all of my vertices for sending to the GPU. So I can't have something where it's like, you know, thread 2, 3, and 4 are waiting for thread 1 to finish writing to color vertex list. So that won't work. I need each. Is it a false positive? I don't think it's a false positive. I'm fairly positive that this would happen. Yeah, I think I need to make it so that I need to basically make it so that like it's a single function that I can easily go put into their own Go routines and multi-thread, but then also when they're done, all of their datas come together, get added together, because they can't be touching the same thing. They can't be touching all the same variable. I believe that's the issue, or I believe that will be the issue. Sketcherson says, I mean the race condition. No, I don't think it's a false positive. I don't have any proof yet, because I haven't tested it for a race condition, but knowing how race conditions work, that would be a race condition if multiple objects touch the same variable at the same time, and if multiple threads touch a variable at the same time. So instead, we're getting there, but I think I want to make a specific like thing for this. Yeah, this is going to be a race condition here. So how would I make this not be a race condition? So when you go to render an object, it runs this function, which I assume would push stuff through a channel to the different threads. Oh, that's right. I'm doing this like I'm multi-threading this part. So let's say you have 3 objects that you're rendering, 3 solid objects, as in this example. We create a thread, or create 3 threads. We push one object onto each thread. So object 1 goes to thread 1, object 2 to thread 2, object 3 to thread 3. When we render, they all are going to be pulling from the same camera. We could clone. So this is where we're multi-threading. When we push it to either when we start the go routine, or when we push something through a channel to indicate that the go routine that's always idling should start. Either one of the two. Okay. Let's do it like this. The only way to get around it is to buffer or finer grain lock so less is locked at once. The only thing that comes to mind, like, right now, excuse me, the only thing that comes to mind right now for a solution is to simplify this so that we are kind of dealing with, rather than solids and transparents, we're dealing with just a single list of objects to render, firstly. Secondly, just because that makes it a little simpler. But secondly, I'm thinking I could clone the necessary data, because like the camera position or maybe even just the entire camera can be cloned for each thread. That's really wasteful, but you might only need to do it once per game or per scene essentially. But at the very least, I could clone the necessary data like the view projection matrix, the light list. I think it's fine if multiple threads read it at the same time, as long as one isn't writing at the same time, right? Let's see. Okay, so this article says, I did not mean to add that to my bookmark list, hold on. Occurs when multiple threads try to access and modify the same data, e.g. a memory address. If one thread tries to increase an integer, hold on. One thread tries to increase an integer and another thread tries to read it, this will cause a race condition. If there's no threads writing to the same memory, it's safe to read, but if at least one writes, then it's a race condition. Okay, so as long as we don't modify the view projection matrix, which we shouldn't, as long as we don't modify the scene, which we shouldn't, as long as we don't modify the light list, then we shouldn't. So yeah, this is fine. All right, so let's keep going. Let's keep going. Yeah, so okay, so that's a little bit of a simplification there. Then we can just do this. We can sort these. This sort triangles or transparents, sort solids. I'm not certain if the length of, well, it does seem like, yeah, all right, so I was wondering, like, do I need to have these length functions? But it seems like we might. So we're sorting the solids and the transparents as necessary, but we may not need to do that. We're just doing that there. We can just really do that separately. That's a little unreadable. Let's keep it like this. Okay. So, okay. Solids, transparents, render. Scene is not equal to nil. So we're setting rect shader options. That's fine because this is going to be rendering out inside here. Yes. Okay. So the go routine then is probably going to start inside of this render function, where we call the model, we apply the triangles, and then we render the depth map and render the color map. Oh yeah, but this is where we might get into issues if we're reading and writing to the same thing at the same time. But this might not be an issue because, oh yeah, vertex list index. Okay, that's where we're going to run into some problems. So each thread would need its own, like, array
to work with. Its own vertex list variable. So then we can set the variables in this like secondary list, then push it to color vertex list when we're ready. Push it to color vertex list when we're ready. When we're ready. We can also use a wait group. Yeah, well, we can't wait. That would only make it slower. In order for multi-threading, or rather concurrency, I guess specifically, to work, they need to be running completely concurrently, which we can do. So we could put a vertex in each vertex. We could put an Ebiton vertex in each vertex of Tetra 3D, so that we basically always have access to our own vertices. So then we would be setting it here. But then how do we get it to the vertex list? We'd have to push it later. Okay, so here's what we're gonna do. Here's what we're gonna do. We'll make something like this. I mean, wait, vertex. Oh, that's just the capacity, yeah. So we could do something like this. Max thread count 2. We do something like this. Do I use try list anywhere? I don't think I will need it anymore. So this is gonna be something like this. UI 16. Right. Right. Okay. Okay, make this, alright. And it's pinned.
this. All right, cool. All right, so yeah, so now the idea is that we have we might have 2 or 3 or 4, in this case we have 2 thread indices. So like thread 1 can use the first color vertex list and depth index vertex list and index list, and then thread 2 can use the second one. And if we have 3 or 4, they can use more. Then the upside of that approach is when we're done, we just need to basically smush the vertices together. This is going to be interesting. I have no confidence that this will work at all. Let's see if it does though. So we're going to need, this is fine if return false. We'll return false. They will return at different times, and we'll need the wait group. I'll need a wait group eventually, but or a go routine or however I want to do it. A channel, wait group. I'll need a wait group eventually to like sync up the combination of those variables. So I apologize if I misunderstood, but I can't use a wait group for the accessing of these vertex lists, but I can use a wait group to basically indicate that they are all done with their individual vertex lists, and then they can be combined. That's the issue. Hello, E-Boat, right? Yeah, just popped in to say hello. Hello, welcome to the stream. This is a heck of a thing I'm doing. Something like that should work. So then thread index would be an int here. I need to mess with channels more. I always end up using mutexes and wait groups. Yeah, wait group seems pretty useful. I don't use them that much because I just don't need to, but they're good. So I guess rendering, we're not gonna need that. Okay, so this won't work because we don't have an individual vector pool for oh no, this will work because we're multi-threading. This entire thing is one thread. Okay, this entire thing is one thread. This entire thing is one thread. Okay, we're good. So this doesn't need thread in it. This does. Yeah, it does. Right? Yeah, okay. E-Boat Right says, will you be participating in a Ludum Dare 50 or Ludum Dare 50? Lethal Dose. Okay. LD stands for lethal dose. LD50 is the amount of a material given all at once, which causes the death of 50%, 1/2 of a group of test animals. That's horrible. I'm just let them dare. I have. Oh, it starts Friday. Which Friday? April 1st. I don't think I will be able to. Maybe I could. Maybe I will. Maybe. Do I have anything happening this weekend? I don't think so. I don't believe so. Oh well, that does change things. So I'll have to think about it. I might participate. with Tetra 3D. If I can get this up and running by Ludum Dare, hopefully I'll get it running by today. But if I get it running in time, then maybe I'll manage to squeeze something out. I'll have to see. All right, so here's what we're gonna do. We're gonna take this and VX. We can't do that, actually. We need to access it all the time like this. Okay. So this is the idea here. No, we don't always need to do it this way. We can replace this with the index, yeah. Is this T? Yeah. Okay. Okay, now this is where we have to say that. Okay. Color vertex list. Oh, that's why I did. Oh, yeah, that's true. Yes, that's true. That's true. This would be red index, right? The vertex, yeah, okay. Like, if it works, then nothing should change immediately. Because I still haven't actually multi-threaded anything. I'm just setting up the data. Okay, so that's better. I always wanted to give myself, try myself on a Ludum Dare, or Ludum Dare. Always wanted to, or rather, maybe I'll give it a shot. Yeah. Going to participate in 50. Yeah, it'd be cool. I think I'd like to give it a shot. See what happens. Okay, so here, we're already looping the triangles, right? Yeah. So we don't need the triangle list. Because we already have the light colors, so we can just say like that. Light colors is this. For I in range light colors I is 0. For light in range lights IV. Light colors I plus equal V, and then thread index. I could make this easier. How long does it take to dereference a pointer? How long does it take to dereference a pointer? Is it slow? Dereferencing pointers isn't free. Okay. It can add up. Sharing data via pointers will heap. Okay. All right, so I want to try to, I don't want to dereference pointers because I'm going to be doing that a lot if I make these pointers. So I'll leave this the way it is. Okay, so we should be good to move on here. So lighting is done. This is, yeah, debug info. I'm not sure what I'm going to do about debug info because this is just going to be a time suck here. I guess I could return a debug info instance. Yeah, I gotta see how I want to do this. Yeah, I gotta figure out how I want to approach that. Okay, so here, apply triangles, int not enough Okay, render pair thread index. Okay, so this is gonna be 0 for now. Index list. I. Okay, there it is. I was. Okay. So, okay. All right, so here is. Oh, wait, yeah. This is where we. Right. Okay. Undo. So this actually is not here. Something like that. Vertex list index, or rather, yeah, vertex list index, thread index. Okay. Camera.cull model. Apply triangles. Cull model to apply the triangles. Max vertices. Max vertices. So it's thread index. Oh, this won't work, will it? I think what we need to do is we need to break this up into two different functions, one for preparing the models and the one for looping through and rendering them all. Because we want to prepare all of the models and then we want to loop through and render them one by one. So that's what we'll do. So this is prepare, and then this is render. Render doesn't do any of that. Render just does this part. We can still grab this though. So render is this. So here we say color vertices is something like this. Depth. This, okay. So this would be color vertices. And then, or this is depth, okay. Depth vertices. Index list, okay. Okay, so here's where we set the stuff that we will be working with. So vertex list index is 0 here. Index list should also be Is there any way to clear an array? Clear a slice? Like, can I do like this? Like that. Let's see. Alright, let's do a test. Let's see if this works. 0, 1, 2, 3, blank 19, 19, 1, 2, 3. Okay, so it doesn't like clear a pinned 0. Yeah. So I have to call make. There's no way to clear it easily. I'll have to loop through. Okay. So for the vertex list index is just that. That is fine. Because basically the current how far through the thread is. Okay. For I 0, I is less than length index list index. Let's well, index list thread index I equal 0. Do I need to? I don't need to do that, do I? Because the index list, it doesn't matter if there's garbage in the index list because we're only going to pass a selection of it. That makes sense. Okay, so yeah, we don't really care about that. So this is where we get go home. So we're not gonna have it here. Making a vertex list of this size is gonna be just massive. So instead, we're gonna have a master color vertex and depth vertex list here, like so. Oops. Okay. All right, so that's the idea. All right, so we're not gonna have this here. Instead, we're going to loop through each result and append it to, or have the color see here. Master color vertex list was append master color vertex. We can't do that, can we? List I the index plus plus non-boolean. Oh, I is less than. Okay. We say master color equals or the. Ooh, okay. We'll just do it like this. Index equals color vertex list I the index and then index plus plus. Do the same thing for depth. All right, that's the idea. I believe this should work. Then we have the master depth vertex list. Oh, I guess we'll need a master index list too. Which is unit 16. All right.
index list. All right. All right. Master index or index list. Yeah, okay, there we go. All right, so master index list. Vertex list index. So I guess it's just gonna be index here. Oh no, because you can have different indices for. No, you can have the same indices for color and vertex in depth. Undi says hello. Hello. Welcome to the stream. I am almost lost in the sauce, but not truly yet. Lost in the sauce. I am in there. But not quite like swimwear. I am largely in there, but not completely. I think this should work. We'll need image. Where's image? Did I not set the UV values? I'll have to double check. Waiting in the sauce. Yeah, I'm basically wading through the sauce. That is fairly accurate at this stage. Like that's fairly accurate. Just to be brutally honest with you, that's fairly accurate. img is equal to rp.texture. Prepare is not being used yet. Okay. All right. So this stage, so we have prepare and then we have render. So we have prepare, we have render. All right. That was a lot of work, but I don't know if this will work at all. We'll see in a couple seconds. All right, let's go to just a simple example because I want to. Okay, I was about to pop off so hard. Man, I was about to pop off so hard. All right, let's see. V index, vertex list index, thread index, and out of range 1 with length 1, thread index. Thread index is 0. Did I not apply triangles? Thread index. Did I only make one? Yeah, I only made one. Why did I only make one? Color vertex. Oh, whoops. Thread. There we go. Better. Okay, that's correct.
All right, so we got all the way through prepare. So now we're in render. Let's see. Index out of range 0 with length 0. Index of what? Give it to me again, but this time give me the right index, line index. Let's see. Here we go. Okay, index out of range 0 with range 0. It's either master depth vertex list or depth vertex list. Let's see. Vertex list equals a pin depth vertex list. Okay. Master depth. Yep, it's this one. We'll see if this works. I feel like it might actually work, but I have to see. I'm cautiously optimistic. Master index list I. Okay. There we go. V index and append. Okay, that's the issue. Right. Index out of range 2 with length 2. This has to be the index. No, index is right. Index out of range 2. Bundi says, do you play any other instruments other than piano and keyboard? Not really. I used to play drums. Many years ago when I was a kid, but I just kind of fell off and stopped playing them. Then we sold them or gave them away actually, but yeah, I used to play drums and I would like to. I kind of want to go back and play them. I went to a guitar center once and like messed around and I was like, man, it feels so weird. It feels so weird, like the timing, and I used to be pretty good, I think. Like, well, for like a 14, 13-year-old kid. All right. I'm almost there. I'm not mind flooded yet, but I'm getting there. I'm getting good. Okay, so master color vertex list. This honestly doesn't need to be in a function, but master color vertex list index equals color vertex list thread index v index. Master depth vertex list index equals depth vertex list thread index for the index. Oh. Yeah, this is gonna be a problem. Hold on. Vertex list index needs to be where we break. Here, the index. What instrument do you think you want to learn the most? I like the hurdy-gurdy. I like the hurdy-gurdy. I like to listen to it. Like, I just think it's a very unique instrument that, like, if you actually brought out a hurdy-gurdy, like, you're basically like a mastermind. If you're like, oh, would you like to hear, a song? I can play you a song. And then you bring out like this big old thing and you're just like, or actually it's lower. It's like, it's just like, what? Like, this man's so intense. How much is a hurdy-gurdy? I gotta look it up. It's, yeah, it's up here. It's down here. I was saying like it's up here. It's low, but I feel like it'd be a lot of fun to just like get good with it because it feels so weird, and it looks like there's. I don't know if I want to pay $1,000 for one, but like I would like to have one. It's a very underrated instrument. Yeah, I think so. Alternatively, a violin is good, or drums, or I mean, piano, of course. But like in terms of musical instruments, I want something very unique. I feel like people are, most people learn like the piano or maybe like the guitar, and it's like those are nice. Those are nice instruments. They do what they do very well. But I just feel like if you have your choice of like I want to learn any instrument, like why not learn a woodwind? Why don't you learn a clarinet? Clarinets can be so moody and deep and soulful, and I feel like they're kind of underrated too. I feel like the saxophone and the like trumpet are like kind of the modern or the well-known woodwind instruments, but then like the clarinet is such a like it hits when it hits very deeply. There's a couple of instruments I would like to learn. Let me take a quick look on Amazon. I just want to see, is there a hurdy-gurdy for sale? Like there's puzzles, but there's no like actual hurdy-gurdy instruments. It's unfortunate. Aw. A 12-hole ocarina. I almost said ocarina. But no, Snow Bazzara says, I missed the beginning of the stream. What are you working on? So right now I'm trying to multi-thread Tetra 3D. That's the goal. And I think I'm almost done. I just need to basically fix like the bugs that are preventing it from running, because I think the theory should be there. I think. We'll see. All right, so index out of range. So that is here. So I'm guessing it's the color vertex list thread index. Is that? Did I not color vertex list? Was it pinned? Color vertex list. It was a pinned. I assume it's not talking about this. Yeah, no, it's not talking about this. Is it talking about color vertices? A nickel harpa? I've never heard of it. Here's all of our vertices. So this definitely is big enough. B index. So then if there's no, so we're getting 3 values, so I guess it must be that master color vertex list is, okay. This is, yeah, my bad. This is incorrect. It should be, yeah, okay, I see what I did here. We'll just go like that, that's fine. Or we'll just go like this. There we go. So we'll see if this works. Hold on. Get rid of those prints so that it doesn't like go super slow. You can use go run dash race if you want to make sure it isn't that. Yeah, it's not, I don't think any of these are race conditions yet. Length modulo 3. Length indices modulo 3 must be 0. What is index at the end then? All right, well that at least means it's going to the GPU. It's just, or going through Epiton. It's just this value must not be correct. 14. It's supposed to be 12? Is this? Oh, yeah. It might be like, the index. Ooh, mamma mia. Maybe we need to do this. Mama papa bricolini. Yo. Okay. Okay. All right, hold up. Hold on. We might actually be pogging. Ladies and gentlemen, we might be pogging. Okay. So, this seems to be working. I forgot to mention that I also added Frustum Culling. Previously, Frustum Culling worked by like, let me just this is the camera, this is the near plane, this is the far plane, and so the previous version of Frustum Culling put a sphere here and of this radius, so it was like this. I guess actually it was probably more like this, I guess. Maybe twice the, bigger, maybe slightly bigger than the distance. Either the distance or slightly bigger. So objects that were, around here would be visible. Objects that were around here were not. That's how the previous Frustum Culling worked. Now I rewrote it so that it actually does work properly. So when you have, something like this, objects here are visible, objects here are not visible, like that. So anyway, Frustum Culling has been rewritten, so that's cool. So yeah, you can see the rendered, oh, the debug, I forgot about the debug stuff. Right, so how are we gonna do debug? That's the thing. So each thread is going to basically be able to say, like, I did or did not render the object or a certain number of objects or whatever. So how do we make it work? Also, if I forgot, if it's not cold, then we can return. Let's see. Am I doing this twice? Total parts? No? What am I? Drawn parts. Okay. So how do we do this? How do we do this debug issue? Okay. I gotta come back from the dead. All right. What I'm gonna do, I guess the only thing that comes to mind is I'll have to make a debug struct that the function returns when it's finished. Either it returns it or it uses a channel. Either one would work. But if we're going to be waiting on a wait group, then we might as well just return the struct that basically says what the object did, what the function did rather. I guess. Let's see. So we called prepare, and here's where we would basically make the debug thing and then go from there. Snow says, I may use Tetra in the upcoming Dungeon Crawlers game jam. Oh yeah, feel free. Before this like multi-threading thing that I started on, it works pretty well. It honestly isn't even that slow. It's just slow if you have a lot of if you're mixing a lot of I think it's slow if you're like doing a lot of individual draw calls, but if you can optimize and push stuff together, then it should be fine. Yeah. So you want to merge basically things that don't move. You want to put them together, and that should help out a lot. But then multi-threading is going to help as well. Okay, so the idea here is that we create a debug thing is, let's see, where do we draw triangles plus equal frame time dot since frame start? It's up here. It'd be someone awesome if someone made a starter template like Abby template with Tetra in it. That might be cool. I feel like Tetra is one of those things where it's like it's really simple in that, like, when you have the basic Abby start, you can just kind of start using it, Tetra. Like, there's not anything else other than just creating a camera or importing a GLTF file and then clearing the camera and drawing the result. Like, clear the camera, draw the stuff, and then draw the result. So like the starter template would be more so just like if you wanted to have an example that's just kind of like a basic example. I could add that. I could just add a simple example, which I guess I can do. I'll do after we do multi-threading. I'll add a simple example that just draws a cube. I'm not sure if I should load a GLTF file or not for that, but like I can do something simple. But it should be like relatively easy. Most of the code that you write when you're using Tetra 3D and you're like just starting up your project is going to be the Abbyton, like creating the game struct and creating its like layout and stuff. Right, so this debug stuff. So transform vertices. So there's debug here. Yeah, because we need to access them in these multiple individual stages of calling the model, transforming the vertices, and then applying the triangles. So we need to pass the debug object through. Really, prepare is where we can do a lot of the debugging. From there, we can kind of leave everything else the same, like frame time. This is no longer accurate. Render time can be here. Let's see. Why didn't I? Why didn't I do it like this? This is interesting. This is not an average at all. This is just the frame time taken once every second. It's really a stupid way to do this on my own. I'm like, this is stupid. Okay. Render time. Did I not type render time somewhere? Pizza time? Let's see. Oh, I just said frame time. Render time. because we do this, right? Yeah. So, yeah, all right. All right. So let's see. Render time is this. Drawn triangles is this. Can we push this? Oh, it's draw columns. Oh, I guess it's fine. I'll just say up to here. Lighting, frame time. Lighting time. Okay. Okay. Render frame time is just going up. Average render frame. That is because we forgot to reset it. Render time should be this. Yeah. So I forgot. Wait. Wait a second. Did I render time? Plus equal, right? Plus equal time that. Oh, I guess I did do it. All right, for some reason I thought I didn't do it correctly. Never mind. No, wait, did average frame time. Oh, I think I think it's off. Okay. Yeah, I think they're off center or something. I'll have to examine that later. That's really aggressive. I'll examine that later. Never mind. Let's see. Let's keep going. No, let's make sure it works. Make sure it works right the first time. Yeah, this is way off. Why is it so aggressive? Oh, is it like scaled up? Oh, it must be scaled up. Yo, okay. Frustum Culling. Sphere and Frustum. World radius. Scale. Hmm. Oh, that's probably why. Let's do that. That is not why. Let's see. Max scale 1.0. Scale. Screen already used. All right. Oh, I see why this isn't working. Okay. Logo BG is 1.4. Why is that so small? Logo BG. Oh, scale. Wait. Wait a second. Okay. Yeah. Logo BG is 4. Logo text is 2. Am I not setting the bounds here? Let's see. The radius is model.mesh. Yo. I had no, I forgot. Model dot scale. Whoops. That won't work. Hold on. In order to fix this, I need this. There we go. Better. Yeah. Better. There we go. Now it's shutting off properly. Fantastic. Okay. Okay, cool. So this works. Render frame time. Yeah, 0. Yeah, it's rising. Okay, cool. Oh, yeah. I was like, wait, why is this not? Okay, hold on. Average frame time. Because this isn't this the tick. When is? That's what should happen. Well, actually, this is fine. Just the times. Because then, if this works. Yeah, I think this should work. Divided by. Excuse me. Yes, this is fine. Let's see. Oh, it's, let me see. Does that make sense? Tick count plus plus after each render? I'd rather not, but is there another way to do it? So we're ticking. So we're ticking, tick, 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 tick. I guess we don't have to do that, right? We don't have to have a tick count necessarily. We could have a tick start, right? then we can say so you say that's a second. So that gives you how much time per second. That might work. We'll see. Hit count. No. Like we need to divide this by 60 basically to get the average. I guess we can just divide it by the frame. Maybe, let's see. Maybe we can go every 10 dot. There's no target frame rate, right? FPS? FPS? Maybe that'll work. Maybe. Let's see. Okay, that might work. Let's see. What is it? 60? Just default to 60 FPS for a start. Alright, that's better, I think. What if we don't do this? What if we say TC is time.duration 1? Okay, so if we look at the entire scene, we're seeing like 3 milliseconds. You divide by 60, that's 0.05. That's about right. Okay. I believe this is a good approach then. So now our averages are averages instead of being something else. So if we go to stress, do we get some nice round numbers instead of numbers that jump around a lot? Yeah, it's better. So it's like 6 to 7 milliseconds rather than being like 3 and then like 10. Now it's like 5 or 6 or 7. Yeah, it's better. Okay. Cool. All right, so if this is working, then we should be able to start multiple. We should be able to basically go thread these, like thread this process of preparing the vertices. So we'll say thread index here as an integer, and oh yeah, that's right. We still have to figure out how we're gonna approach this race condition issue. Man, I don't really want to have to deal with it. Is there any way we can avoid dealing with it? No. Okay. Oh. We can make it so that the prepare function returns the go routine. Because I think that's the only thing that is go routined out, right? Or I'm sorry, it doesn't return a go routine. It returns the debug thing we're looking for. Okay, this will work. I guess the render pair can have the debug stuff in it, because that always has access to it, but it's not a pointer. Do we care if it's a pointer? We do kind of care if it's a pointer. We would like it to be a pointer. Okay. All right. All right, so if this works, then we should be able to just run it. It shouldn't crash or anything. All right, looks and feels good. All right, so now from here, we should be able to then create the things that we need to create here. So total parts, total tries. Is that more or less it for that? Let's see. Oh, that's too few values. Okay. Because render, I think render, yeah, we can directly touch that. That's fine. But I see. But transform vertices does stuff. Okay. Or not transform vertices, but rather, well, it does. It does do a little bit of debug stuff here with the animation time. Times this T. Render pair. That's good. This is good. Okay. All right. So we'll walk it down in sections. So here, the debug total parts is here. So instead of this, we'll say pair.total parts. I guess we can just keep it the same. Like that. Pair.total tries. Okay. Okay. Yeah. Well, this is going to be a little tough because the amount of time it takes to animate, like we have to basically average that out across the threads. It's not really an easy way to do that. I mean, there's obviously we can average it out across the threads, but I'm saying, I guess we would just take the max value. So if it's, let's say 3 seconds or 3 milliseconds on one thread and 0 milliseconds on another thread, then it's 3 milliseconds. Yeah, okay, I guess that's what we'll have to do. Oh, I was like, what is this? Okay, pair dot debug drawn parts. Okay. Drawn parts. Okay, so then this is model. This is matched part. All right, and then that's done. Rendering is done. Okay, so debug for total parts. Okay. Parts. Parts. Okay. Animation time. Does that make sense? Animation time. And then lighting time. The reason why we have to go with the lowest value for the light time and the animation time is because it's multi-threaded. So we're waiting for the threads to, we have to wait for the threads to complete. So the time isn't like invisible. It does exist. Like if you spend 4 seconds, let's say you have 16 milliseconds. Let's say you spend 1 millisecond rendering and then 2 seconds rendering on another frame, on another thread, and then half a millisecond rendering on the third thread, then you waited 2 milliseconds basically, right? Because when you were 0.5 milliseconds through on the third thread, it was then done. So that it was doing nothing while the second thread was doing what it was doing. So anyway, this is where we basically say, well, wait, we want to prepare them all and then render. Yeah. There we go. We want to prepare them all, and then we say if render pair. Okay, so I guess we'll just have like add an light time. If render pair.debug animation time. My brain is like, my brain. So this is basically per thread. We want to I don't know, man. For now, I'm a little lost in the sauce. I'm a smidge, just a smidge. I'm lost in the sauce. I can admit that I'm lost in the sauce. This should be thread index int. Okay. All right. So here's the idea. Yeah, for now, let's just. I'm getting kind of ahead of myself. Oh, I guess we could just. Yeah, we can't do it that way. All right. Well, I'll come back to that later. For now, let's just get this working. So basically, we want to go routine this process and break it up into a couple of different threads, essentially. So we say for I is equal to 0, I is less than max thread count I plus plus. Did I not create something called max thread count? It's here. Okay. Okay. So we basically want to call prepare. Well, if length to render is greater than, well, I guess this is fine. Yeah, something like this. Piece equals 0.0. Piece plus equal, or I guess we could say end. End plus equal length to render divided by max thread count. And this won't work. End. Yeah. So this should be a float. Oh, whoops. I meant. Oh, well, yeah. This also needs to be a float. Okay, so we're taking the number of things we want to render, we're splitting it up by the number of render counts, we're adding end to be, that basically represents like a percentage, right? So let's see, you have like 5 objects. You have a list of 5, you have 2 threads, so it's 2.5. So it's 2.5 plus 2.5. So we want to round it off. So we want to prepare, or rather, for I is equal to 0, or 0 index is less than, start. End plus plus prepare to render index, thread index is going to be I, and yeah, we need to actually, I guess it's going to be like this. Loop variable thread. Oh, I see. Index int. Okay. All right, so that's the idea. That was a lot, but let's see if it works. Let's see if it works. Nah, let's see. Vector pool out of range. Where camera backface pool. That's true. I hadn't considered that the backface. Wait, where is this? Apply triangles. Okay. Yeah, the backface pool. Okay, so backface. Hold on. Backface pool reset. So here's what we're gonna do. We're gonna reset this. How often can we reset this? We should reset this basically every triangle, but we can't do it that way. But we got all the way down here. Is this? Yeah, I guess it must be. Backface pool. do have a vector cross. Fast sub. All right. Nah, I don't want to have to do that. We should have a backface pool, so I guess we'll have to make different backface pools for each thread. I guess that's the only thing that comes to mind, so that's what we'll have to do. Let's see if this works. Model that vector pool. Apply triangles. Okay. Transform the vertices. Oh, yes. It should be fine. Is there two threads working with the same model at the same time? That should not be the case. Although I guess it's a possibility. Yes, that is a possibility. Okay.
Start and go func start. Yeah, I guess what I'll do instead, maybe I'll just make a piece and start. Something like this. So it's basically render index is equal to int start from to let's see. So if in this example, what I'm trying to figure out, let's say you have 5 objects, right? You divide that by 2 threads. Now you have 2.5. So the first one could go from 0 to 3 or 0 to 2, but the second one needs to go basically from the rest, from that point forward. So let's start. So we start plus stick. I wonder if I should if I should do this in a different way, where you divide 5 into 2 pieces. Should I divide the objects before I even run the go routine? Should I do something like this? And then the start would be so maybe something like this. So go multi-thread PI start size. Then we add the size to start. We round it off. So I guess this would be math that round. So this would be 2.5 start equals, okay, so start would be out here. Size can always be out here. All right, so something like that. Index out of range 4 with length 4. This goes from 0 to 3. Then it goes from 3 to 4. I see. Okay, so if all right. At least it started. Let's see. Backface pool. Backface pool. I get the concept of why this is crashing, because thread index is 3. I'm guessing. Yeah, this isn't working. Oi! Zyodic says, hello, what are you working on today? I'm trying to
to multi-thread my rendering engine, or at least as much of it as possible as I can. And as you can see from my previous stance, it's not going well. it's going poorly. Oh, I forgot. We have to wait. We have to implement a wait group. So we wait for this to complete. Okay. Well, at the very least, it's working. Let's see if there's any hope of this working, of this actually doing something. I think it's just one piece. Yeah, I think it's just one piece of it. Let's see. Max thread count 2. Oh. No, that should work. Let's see. Prepare for render index from plus. Let's see, append to render. Wait group. And then next, let's see. Okay. At least it's not. At least it's not crashing. But it's definitely not working properly either. I think part of it is it's skipping elements. It also might be like doing just the depth part. Let's see. Render frame time. Wait group. Oh, it's wait group add go multi-thread. Oh, I wonder. No, yeah, surely this isn't a problem. Oh. Alright, that's part of it. Can we round this off? Make that round. We don't have to not round it off. Is it ever doing done? Yeah, it's doing done here. I'm not sure if I should pass the wait group, so I guess I'll do that just in case. Can't hurt. Let's see. Okay, I'm guessing. There we go. I'm guessing this isn't working because this is calling done on the wait group, but the wait group is not a pointer, maybe? Not sure if that makes a difference. All right, better. Better. I think part of the issue is that it's not drawing the right objects, and so it's like flooding the index buffer or something like that. So render index is less than from plus size. Render index plus. Well, actually, this could just be float 64s, honestly. It's better to use ints for this. This can also be an int. Prepare to render index, thread index. All right, let's do something real quick. I want to try troubleshooting something. Let's say we only have one thread. Does it work? No. Okay, well that kind of indicates what the issue might be. From should be 0. There's both 0.2 and 0.4. Go multi-thread. TI int start int size. What? Oh, no, that's right. It should be 0.2 and 0.4 because it's rendering twice. Oh, hold on. Is that an issue? Is it a problem that it's rendering twice? Let's grab this one. Because I'm rendering these nodes. Drawing to the off-screen buffer and then rendering these nodes without clearing it again. But I don't believe that should be an issue. Unless prepare. Yeah, it might be an issue with this specific scene. So I'll double check this in a couple seconds. I want a simpler scene that might show something a little bit more indicative of the issue. Well, this cube is drawing, but it's not drawing the other cube that I know is there. Where are you at? Where my boy? Where's my son? Where's he at? So is it not drawing the whole scene? It's drawing 2 objects. Or at least it should be preparing 2 objects. Let's see. Index list. Prepare. Is this all? Wasn't there like a third a third step? It was cull. Oh, transform vertices is used in here. Okay. Yes, okay. So call the model, transform the vertices, apply the triangles. Call the model. No longer call that's true. Vertex list index, thread index equals 0. X plus equal 3. Oops. Parent and child. Oh. So after we prepare, oh yeah, okay. So this vertex list index thread index needs to be set to 0 out here like that. There we go. Okay, so this is working. So now we should be able to go to here and set maximum thread count to be 2. And now there should be 2 threads drawing each cube, or 1 thread drawing each cube, rather than 1 thread drawing 2 cubes. But now there's an issue. Interesting. Let's see, from size. So I don't think the issue is, wait, from size, from size, yeah, from size. So from and size should be correct, but the issue might be that it's, could it be that it's not drawing that? No, it's always starting them. Maybe, let me see, hold on. So when we go to render, we're stepping through the results basically in order of thread index. Is it naive of me to assume that the threads will start in the order that I'm calling them? That seems logical, right? Like if you call go function and then later on you call another go function, the second one should start after the first one. That it's possible that that is incorrect. You can have them both log something. Maybe so. They can start in any order depending on other tasks running. Of course. Okay. So there's no, that must be the issue. So there's no reason, so to speak, why calling this, like, do threads have unique IDs? When I start them, yeah, I'm passing the ID that they are, but there's no guarantee that this, if I run this function concurrently with ti thread index being 0, and then I run it again concurrently with ti being 1, there's no guarantee that 0 will start first and 1 will start second. But that shouldn't matter. It shouldn't matter. No, it shouldn't matter, because yeah, it shouldn't matter. Shouldn't matter, actually. Yeah, it doesn't matter, because we're regardless of when we're which ones start first or second, one thread is going to be observing one object, and the other thread is going to be observing the other object. It doesn't matter what order they go in, because we're just going to start them. They're going to do their thing. We wait until they're done, and then we look at the results to draw them on screen. So why is it that when we have two threads, it doesn't draw correctly? And you can see rendered triangles being incorrect. $16.24. It's not consistent. Multi-thread equals thread index from size big group. We're calling the models. This is probably going to be a problem now I look at it. Yeah, this might be a problem. Yeah, might be a problem indeed. That should work. That should work. Let's see. Vertex index, thread index. Plus equal 3. Turn 0. Apply lighting. Okay, yeah, so not there. So this can just turn this. This can go actually. Continue on a different triangle. I'm once it's there, I'm gonna be pogging. Like, the fact that it works with one thread seems to indicate that the fundamentals are there. It's just a matter of other issues. Also, let me just what do we got here? Memory is not super high, which is good. Okay. All right, so yeah, what's the issue, or what could be the issue if we have multiple threads? Thread index. Let me change the music. I haven't heard this in a while. Max versus. Why would max versus be 0 ever? You can skip triangles that lie entirely outside of the view, horizontally and vertically. Let's get rid of this stuff. I feel like there's more of it, but it's still exhibiting the same issue. So that didn't solve the problem. The problem is still there. Okay, so this tells me that there's definitely something else going on. Thread index 0, 12, thread index 1, 12, 0, 12, 1, 12, 0, 1, 0, 1, 0, 1, 0, 1, 0. Yeah. 0. 0, 1, 0, 0, 1. How is this happening? Zero, 1, 1, 0. I guess it's 0, 1, and then like it might run 0 and 1, it might run 1 and 0. Prepare. Break. Done. Ridiculous index. Thread index 0.
Maybe this is the issue. Maybe it shouldn't be here. I don't think it should be. Race detection maybe make it obvious. Maybe so. Is it a race detection issue? Well, I mean, no race detection results yet. Nothing seems out of the ordinary. Wait. Oh. Vert transform 2 plus near divide by 4. When we're applying triangles, this is a race detection, but oh, you're right. This is the race detection. I forgot, dude. I put the transformed version of vertices directly on the vertex, but that won't work because multiple models can share the same mesh. So if two models point at the same mesh and two different threads are rendering those models, then they'll be both modifying the same vertex transformed at the same transformed value at the same time. That's what's going on. Okay, that's why this isn't working. Understood. All right, let me undo the stuff I did that I commented out with regards to, yeah, that's okay. So what we'll need to do is we need to have each thread or each model have its own transformed version of the mesh. Which is fine. It's not really that big of a difference compared to how I'm doing it now. Not really, but it's just a minor change. So instead of it existing on the mesh, it now has to exist on the model. Because the mesh has multiple mesh parts, yeah, okay. Okay. Link mesh dot. Okay, so the number of triangles times 3 is the number of vertices in the mesh. So we're making a slice of vectors here, which we could... We don't have to fill them. I don't think. Let's see. Yeah, this is no longer here. Multi-threading is much easier with race and some cool libs like Go Deadlock and Size Rate Group. But yeah, it's definitely useful. I just completely forgot about this. Now I'm trying to figure out how I can walk through this properly. The tries are the transformed... Oh.
This is fine. Vert.uv. As long as we don't assign to the vertices and things, we should be fine. So I think we're good, but we'll need to loop through. Do we need the triangle itself if try.visible? Yeah, we do. Okay. If we are looping through the triangles in order, then that means we are looping through the vertices in order by just necessity of how that works. So the triangle's vertices are always going to be the index of the triangle times 3, more or less. Yeah. All right. So here's what we're going to do. So transformed vertices now doesn't store it here, but rather stores it here. Step 3. It's redundant. I think that's right. I know this won't work. I'm just trying to see if... Yeah, I think I have to just do it like this. Okay. Vert.transformed. Yeah, okay. Vert index. Index. Okay. Now this is going to be, we need try index here. So this is going to be mesh part dot, or no, model transformed vertices try index. What is this? This. And then here, vert I plus I index. Okay. All right, maybe that'll work. All right, at least it just crashed. There's still a data array somewhere. Calling the model? Previous read. Right here. So we're writing. Let's transform dirty. Oh. Okay. All right, I think I see. This is also a race condition because when we call paradigm model transform. I'm guessing it's modifying. We're two threads are modifying maybe the camera's transform. So we might need to call transform before we do anything else. Okay, let's see. So this is render. Let's see. So this is solids. If model not matches. Do that. That might help. Transform vertices. This is more complicated than I anticipated. Try that depth. Yeah, it won't work. Because we're modifying the triangles. It's easy to miss something when adding in threading after the fact. Yeah, I'm not certain if I would have been able to do this better if I designed it with threading in mind. I don't know. It just feels like there's some like this is just kind of impossible if you want to do threading. Like you can't put. I've been just putting stuff on data structures as a place to put them, and it worked okay until now because it wasn't multi-threaded. We can't modify stuff. Can we sort data structures? No, this sorting mesh parts also wouldn't work if it was multi-threaded. This triangle list would have to be somewhere outside of the mesh because that lives. Well, no. Yes, because two threads are modifying it at the same time. Can you invoke something on the main thread of the side thread? I don't know what you mean. Main thread of the side thread? Do you mean main thread or the side thread? Let's see, mesh part. Sorted triangles, I, J, depth. Okay. What I'm going to do, I'm going to stop. I've been thinking for like 3 or 4 hours, so I'm going to take a break. I'm going to come back to this probably and rethink how I'm going to approach it. Fundamentally, I'm doing things that just is incompatible with multi-threading. Like Carl said, this wasn't designed to be multi-threaded from the start, so I'm just doing things willy-nilly that are probably bad. There might be a way around it. Yeah, some things might just need mutexes, or I might just need to take functionality out in favor of keeping things simple and multi-threadable. Okay, this is fine, yeah. Let's see, because we have a few things that are problematic. This is problematic. That's problematic. Maybe that's roughly it. Maybe there's just a few things here. So I'll just have to figure out triangle being visibility being influenced or being able to be influenced by a transform function. Honestly, I could probably just turn that off. Turn this off, because if you are using the transform function and you want something to just like disappear, you can just like set the vertex position to be all 0 for the triangle. Like that also would work. So it's not a huge deal. So that might just, I'll just do that now, I guess. We don't need this visibility. Means we can just, yeah, that's fine. Depth being stored on the triangle is bad, but where else can we store it? Because we need to sort the triangle by its depth. But two objects could be drawing and they could have the same mesh. So would I put that... How do we sort a triangle without referencing the triangle? A map would be slow. Try to depth, try to depth, try to depth. I guess it'll have to be on the model. I guess it would have to be, that's the only, not the only other place we could put it, but that is a logical place to put it. So let's put it on the model, I suppose. So, I guess we could do it like this. Because and also I forgot, we have to, these are vectors, yeah. So we could just, like that. Try depths could be a slice where each index indicates the depth of the ID. You know what I mean? Like something like this, make 0, and then like length mesh. Oops, not actually mesh dot triangle count. Also, both of these need to be adjusted if new model. Okay, both of these need to be adjusted if merge happens. All right, and then, right, we don't have this anymore. All right, try to depth equals 0. Right, so now there's no depth. Triangle doesn't have depth anymore. Instead, we have the ability to modify the model's depth. So model dot try depth try index equals this. And then when we want to sort, we, instead of sorting it by the mesh, okay, we can't put it here. We have to put the sorted triangle. We can't put it here. We have to put it on the model. Everything has to be on the model, unfortunately. sorted triangles here. That length mesh dot full. Let's see. Oh, clone. Okay. Dot total triangle count. Okay, I didn't know I had no such ability to do this. I will put it here, I suppose. Vertex, triangle, okay. No, not triangle. Where's mesh? Guess we can do it this way. Alright, so something like this, then we can say all triangles. For blank, try and range mesh all triangles. Sorted triangles equals append. Sorted triangles. Try. Then, yeah, this might be better anyway. But model not sorted. Triangles equals make. I guess we can just do this here. Move this equals model dot. Say copy. Go to clone. Not clone. Clone? No. Well, I guess we will. But yeah, we will put it here. We will need to put it here rather. Mesh. Okay, so. Oh, almost forgot. Model dot mesh. Okay. And when merging, also. Okay, hopefully I don't do this too much. Okay, so now we can sort the triangles list by the triangle depths and use the same I and J values because they should be the same length. Like this. Sorted triangles. Return this and there's no reason why triangles would be invisible. Model. Maybe? Maybe? Alright, let's see. Try depth. I think this should work. I didn't know I just do this. Right, triangles. Yeah, why did I do it like this? Y'all are supposed to let me know. So y'all are supposed to let me know. New model.mesh.all triangles. Okay. Sorted triangles. Okay, cool. So try depth is where we ran into some issues. I think this should be fine. Try depths. Yeah, try depths. This is if we merge, yeah. Let's see. Right. All right, we're not getting race conditions at the very least. That's good. Yeah, that's not bad. That's not bad. Okay. Okay, that's good. You know what? Let me keep going. I'm too invested in this. All right. So what's the issue then now? Lucretia says, I just got here. What are you trying to do? I'm trying to multi-thread my rendering engine. Oh, it's interesting. It's weird. Seems like I'm getting there. I think I'm getting there. Epilepsy warning required. Sure. That's such a minor thing. I don't think it was that bad. If so, sorry. But yeah, I'm in the middle of trying to multi-thread this rendering engine, which is a heck of a task. But I feel like I'm like almost there. I feel like, is this rendering multiple times? I don't think so. The triangles are messed up here. Transform vertices. Index times 3 plus 1 plus 2. Looks sort of haunted. It is cursed. It is very cursed. Let's see. Transform vertices. Transform vertices. Try index times 3. Mesh part dot triangles. Oh, yeah. Maybe I should, yeah, I see what the issue is. I'm putting all of the triangles on the model, but I'm drawing each mesh part individually. So I probably should put this not on the model, but rather on the mesh part. Oi, all right. At least that makes more sense, and this should work. This should be rather not transformed vertices, or not the tool, but rather do I always add triangles all at once? Looks like, okay. Where's this triangles equals? Okay, so I think I can do something like actually, I guess this is fine because we don't. Why is this not? Oh, okay. There we go. Let's see. Wait, no. The reason why I put this on the mesh in the first place was because it can't be on the mesh part because that's shared. I forgot. I forgore. I think this is fine, right? Or is this not fine? What's this sorted triangles? I moved it out of sorted triangles because I was moving it onto mesh, or model rather. Right, let's see. Sorted triangles. Okay, so when we draw all right, here's what we're gonna do. I think we will do. We'll keep what we have here. So apply triangles. Transform vertices rather. I think what we need to do is work with what we got. So there's a couple ways we could do this. There's a couple of ideas here, but I'm not even sure if these will solve the problem I'm having. That's the kind of crazy thing. No, I guess it must solve it. Maybe. All right. Yeah, I don't really want to have to do this, but I do not have an alternative, I don't think. Hold on. Sorted triangles MP equals well, MP dot triangles append. Okay. I reset sorting variables. Okay, and then try depth. Okay, and then lastly, transform vertices. It's gonna be this is a mess. Should work. Transform vertices. Okay. And we want the length of NP. Okay. Set variables. Yeah. All right, so this might help us a little bit. Because this allows us to basically select the pieces we're interested in. Well, transform vertices, mesh part. Try index times 3. Okay. Try depths. Try depths. Okay, then we say that. Okay, so model sorted triangles is all of the triangles for the mesh part. Yeah. All right. Mesh part depth. Vert index. Over here, we want to clip the vertex. So I guess now we do need this because then we can say vert. So I guess we'll say there we go. Oh, that's what I was missing. Try sort of triangles. All right, something like that might get us a little bit closer. A little bit, not a huge amount, but just a little bit. It crashed. Call a swapper on map value. Oh, you're telling me you can't slice or you can't sort a map value. All right, let's see if we can do this. Oh, that's not what I meant to do. I meant to do match part. There we go. That might be why. Maybe. Still not working right. Triangles, measure by triangles, try it out vertices, transform vertices. Try index times 3 plus vertex vert index. Maybe this is the, maybe there's another issue here. Let's see. Try index 3. Well, the actual positions are right. I think it's something else then, right? Because like the positions of the 3D model is correct. It's just that the UV values are incorrect. So that might mean that this is incorrect somewhere. Let's see. Color vert.uv0, vert.uv1, vert in range tried at vertices. Try index. So we're skipping some. X, Y. For vert index vert range tried at vertices. Source X equals vert.uv0. All right, I'll have to rethink this. I think I'm there, but I'm not sure if I like the result I'm getting. Does it even work? Nah. Is it?
related to a race condition? Nope. The code's just not working. Okay. At least it's not a race condition. Alright, so I'm gonna probably chill out after having fought really hard for like 4 hours straight. Yeah. I'm close, dude. I'm close. Whatever's making this not work is probably what's making it not work with multiple threads. Because if I can get this working with multiple threads, then that can really save time. That might take it down from, 5 milliseconds, transforming vertices to, 1.5 effectively, because you can spread it across 2 or 3 threads. Well, 3 or 4 threads. I mean, like, that's a good thing. I wanna make it work. Let me see. Can I pull the runtime? Is it proc? Yeah, max procs. What is? It says the maximum. Oh, sets. Oh, returns the previous setting. Oh, okay, it was less than 1. All right, so how many processors do I have? I think I have a 6-core, 12-core. Okay, six processors. I guess dual core. I have 12 cores I can use. So that's a massive improvement if I could bring it to life. Yeah, and there's 12 CPUs here reported. So I mean, like, taking it from a program that puts, vertex transformation on 1 thread and kicks it across 12 is like, that would be a massive improvement. So we'll see. We'll see if I can get it working. If so, then it would be better, I think. How fast does it run in the performance test? Currently, it doesn't run very well at all. Well, let's see. If we had... Let's do 1 thread. Let's do 0 threads. Let's do 1 thread and say multi-thread. Okay. Max thread count. Okay, so we say if max thread count greater than 1, then do this. Else prepare to render. Oh, 0. Response. All right, so that's interesting. That's weird. Because I'm clearing it, aren't I? Yeah, aren't I calling clear? I am here. Or clear does work there. Let's see, main.go, is that this? This is the logo, I guess. Gonna get parenting. Yeah. That's weird. I'm not sure how this is happening then. I mean, it's like, it's clearly like not clearing the background, but I know I'm calling clear.
Well, in any case. Let's do the other one. That other stress test is more stressful. Okay, this is running at like 1 frame per second. Somehow. Prepare if called no. It's interesting. So it's running at like 1 frame per second here. Previously, it was running at like 17 frames per second. How did I manage to do that? How did I manage to screw this up? Okay, but it is like a definite improvement. Like it goes from 1 frame per second to like 4. So it does help. Like we can see it definitely is like making a difference. If we say we have six threads, how long does it take? It's like the same. I don't know. I'm bummed. I'm a little bummed. I'll have to see if I can get working. It's a weird problem. Once I solve the problems, I'll see if I can, if it makes a difference. It might be that it just you know, my program isn't really well suited to, or you know, Tetra 3D is just not really well suited to multi-threading. But I find that hard to believe considering how much of it is CPU bound. Like, so you know, transforming the vertices is a CPU operation. Applying lighting and applying, clipping or transforming the vertices to be in 2D space, that's a CPU operation. It should be able to multi-thread that pretty well. So we'll see. There might be, let me save that, I guess. There might be something else going on that's making it run really slowly, where it's just like, oh, I'm rendering 10 times as many objects, or like it's not looping through correctly, or whatever. It's not calling objects. I don't know. I'll have to see if there's something going on, because it definitely feels like it should work, but it's hard to reason with a computer program. All right, I'll catch you guys on the flip side later. It's been real, and thank you very much for watching. See ya.